Hi children, subject computer science for grade 4. Today we have discussed about a new lesson called data and data storage devices. In this lesson, today we have discussed about the topics, data and data representation. In this topic we have three side headings such as what is meant by a data, what is information and data representation. The next side topic is computer memory. The first side topic is data and data representation. In data and data representation, first we discussed about what is meant by data. So what is meant by data? Data is defined as the collection of raw fact suitable for processing. Raw fact is nothing but it doesn't give any meaningful messages. Raw fact means it doesn't produce any meaningful messages. Second point, the data may be about people, places, or some objects. First, you see the example 2, Lada 43. So, these are their examples for data. 2. 2 is just a number, it doesn't give any meaningful information. Lada is a person. Next, 43 is also a number, it does not give any meaningful information. So, this is called data. So, data is nothing but it is a collection of raw fact, it doesn't produce any meaningful information. Now we have seen the what is meant by information. Information is the processed data. In the data we have seen data is a raw fact. So the data can be processed and it give the output as the information. See the picture. The data process information. For example, the data is nothing but adding two numbers 4 and 5. Process means addition. Addition is the process. Then information is nothing but result. For example, 4 and 5 we can add, the result is 9. So 9 is the information. So see the example, data, process and then information. First, orange is the data, that is also called as input. Process is a juicer. Okay, process is the juicer. Next, at last we get the orange juice. So orange juice is the result or information. So once we give input or data, that input or data is processed into information. The orange is juiced into the orange juice. So this is the how the data can be processed into information. See the picture. These are the examples how the data is converted into information. See the picture. CT is nothing but computer terms. In computer terms, we can input, process and output we can say. First example is the computer. We can take the computer as an example. Keyboard as an input. If any information or data is given through the input. Next one, process. Process it is CPU. CPU only process whatever the data given by the user. The CPU will process it. Next one, output. Output is nothing but the monitor. We can display their results in their monitor. Next example, problem. That is a problem in mathematics. 2 plus 3, addition. So 2 and 3 are their input. Next, addition is their process and then 5 is their result. Next, human. In human, what is the input? Whether we can listen or by seeing anything. In our brain, it can store the details. At last, whatever the human think, by using their hand, we can draw, or mouth, we can communicate with. So these are the examples of their how the data can be represented or converted into information. So see the picture. This is also an example for how the data is converted into information. Input, clay. There are different types of clay. Process is child playing with an clay. If you give any clay, you are molding any shapes or there. By using their clay, we can create your own image. So clay is an input, process is by making, and the output is their toys or shapes. The next topic is the data representation. How the data can be represented in the computer. The first point, computer can handle data in the form of zeros and ones. So the computer cannot understand any English or Tamil language. It can understand only the data in the form of zeros and ones. Next, any kind of data like numbers, alphabets, or special characters should be converted to a zeros and ones, because the computer can understand only the machine language 0 and 1. So whatever the data, for example, if you give your name by using a keyboard, means the computer cannot understand your name. So the name is converted into the zeros and ones. Next point, the representation of the data is called machine language. So the computer can understand their language. 0 and 1 is called machine language. Next, 0 and 1 is called binary digit. 0 and 1 we can say as binary digit. The short form is bit. Binary BI, and then digit at last T. So bit is their binary digit. So zeros and ones we can call it as bit. The data can be represented in the form of three ways. One is a bit, nibble, and then byte. First, we see about the bit. Bit is the short form of binary digit, which can be either 0 or 1. See the example, 0 or 1, whether the result or input is 0 or 1. Next one, the bit is a basic unit for the data representation. This is a bit is the basic unit of the data representation. The data can be represented in the form of nibble. So nibble is a collection of 4 bits data. Bits is nothing but zeros or ones. So nibble is a 4 bits, that is a 4 digit number, whether it is a 0 or 1. Next, the data can be represented in the form of byte. Byte is nothing but a collection of 8-bit data. 8-bit data means 8 digits are there. The digit consists of zeros or ones. See the example 11001100. Whether the inputs are whether all the digits are 0 or 1, or the combination of zeros and 1. Example of data representation. See the picture. Your data, it is converted into computer data. Your data is nothing but our data. Our data is in the form of text or picture or numbers. So these type of data is converted into a computer understandable language, that is a machine language. Machine language is nothing but zeros and ones. So each and every data can be converted into computer data. Next, our side topic is computer memory. Memory is similar to our brain. In our brain, we have to store information in it. Likewise, in memory, we have to store the data such as whether the data or images or videos. So, wherever we can retrieve information from the computer memory. So, see the chart for the computer memory representation. 1 bit equal to binary digit, 8 bits equal to 1 byte. Next, 1 KB equal to 1024 bytes. Next, 1 MB equal to 1024 kilobytes. 1 gigabyte equal to 1024 megabytes. Next, 1 terabyte TB equal to 1024 gigabytes. Next, 1 petabyte PB equal to 1024 terabytes. 1 exabyte equal to 1024 petabyte. Next one zettabyte ZB equal to 1024 hexabytes. 1 yottabyte equal to 1024 zettabytes. So these type we can represent the memory in their computer. This is the time to recall our lesson, data and data storage devices. In this lesson today we have discussed about the two side topics such as data and data representation and then computer memory. First, we discussed about the data. Data is nothing but is a collection of raw facts. Example, two, Lata, cow. These are their examples. Next one, information. Information is the processed data. For example, adding two numbers. Adding two numbers are their example. First two numbers are their data and then process this the addition and result as the information. Next, we discussed about the data representation. In the computer, data can be represented in the form of zeros and ones, that is called the machine language. The zeros and ones is called as a binary digit, we can say as bit, bit, bit. Next, we discussed about what is mean by a bit. It is a short form of binary digit zeros and ones. Next one, nibble. Nibble is a collection of 4 bits. Next one, byte. Byte is collection of 8 bits. Next, we have discussed about the computer memory. Computer memory is nothing but each and every terms are represented in the form of bytes, kilobytes, and then megabytes. Thank you, students. I hope you understand these two topics. Thank you.